Hello, students. Today we are going to discuss the application of prisoner value formula or the application of time value of money. We're going to conclude the chapter 4 with this section. Okay, now let me present my slides with you. Oh, come on. Okay, now we understand how to calculate the future value, how to calculate the present value. And now, we're going to look at how can we use the present value, the present value formula or future value formula to solve the issues in the real world. Okay. First of all, let's have a review of present value equation or present value formula. We have a basic present value equation. It is like this, right? Present value equals the future value divided by the 1 plus r raised to the power of t. Okay. Usually, the present value equation essentially, is the reverse process of future value equation, right? So in my teaching, I usually like to use the future value equation. So if we have if we write down the future value equation, then it is future value equals present value times 1 plus r raised to the power of t, right? Anyway, these two equations essentially are the same thing. They are the two sides of one coin. Okay, we can use either of them. In this equation, there are 4 variables. Okay, the first one, here it is future value. First one future value, second one present value, and R growth rate or rate of return. T is the number of times. Okay. If we know, in this equation, we know if we know any three, if we know the value of any 3 variable, we can solve for the fourth. Now, let's look at how can we do that. We have learned how to calculate the future value, how to calculate the present value. Now, let's look at how can we calculate the R. How can we calculate the T? Okay. First of all, let's look at how can we find out the discount rate? I'm going to use an example to explain. Your friend wants to borrow $1,000 from you today, and he offers to pay you back $1,200 in 5 years. Your bank account earns interest rate. Okay, there is a typo. Your bank account earns interest rate 5%. I want to revise it before I forget. Your bank account earns interest rate, okay, 8% a year. Oh. You trust your friends as you trust your bank. Okay, that means this sentence means the risk with your friend and the risk with your bank is the same. Let's suppose they have the same risk. Okay, they have the same risk. Then, is your friend offer friendly or not? Okay, or in the other word, yeah, is your friend offer better? Is your friend offer friendly or not? Yeah, this sentence means, yeah, the interest rate that you can earn in your free, the interest rate that you can earn from the lending to your friend is better than the interest rate that you can earn from your bank account, right? Yeah, if interest rate from the lending to your friend is better than the interest rate that you can earn from your bank account, then yeah, your friend offer is friendly. Okay, so the question boils down to comparison between the interest rate that you can earn in your lending to your friend and the interest rate that you can earn in your bank account. Okay, so yeah, we're going to use a formula. Yeah, you're gonna usually, just as I said, I would like to use the future value formula because yeah, it is I think, in my opinion, it is more straightforward. Okay, so uh we apply the numbers into the future value formula. Future value, yeah, in this case, future value is $1,200, right? Future value equals present value. Present value is 100. Present value is $1,000. Then times 1 plus R. R is what we're looking for, and raised to the power of t. T is 5 years. Yeah, you're going to suppose your lending to your friend is a investment, and then the life of this investment is 5 years, right? Okay, so this is the future value formula. Future value formula, and after we have this equation, we can solve this equation in two ways. One is we can solve this equation mathematically. Okay, that means we use the math to solve this equation step by step until we find the unknown, the value of the unknown. The other way is we can use the financial calculator to find out the solution. All right. Uh, generally speaking, I require students know the two ways. Okay, they should know how to use these two ways to find out the unknown. However, when you're doing your homework, when you're doing your test, especially in the future, when you're working, in the real world, I think most often you would use a financial calculator to get the answer. Okay. So in my teaching here, only in this section, I'm going to show you how to use math to find out the answer. Later on, I will not show you use math to find the answer anymore. Okay, again, I stress, you should know how to use the math to find the answer. occasionally you can use the math to verify the answer from the financial calculator. Okay. Now, okay, how can we use math? Now we have this equation. We have this equation. Okay. First of all, I divide the both sides by 1,000. Now on the left hand side, that should be 1,200 divided by 1,000, right? And on the right hand side, yeah, in the numerator, that is 1,000 times 1 plus r raised to the 5th power divided by 1,000. Okay, so 1,000 above will cancel the 1,000 beneath. Okay, they cancel each other. Then finally we have 1 plus r raised to the 5th power, right? Okay. Now further, I'm going to simplify the left-hand side. 1,200 divided by 1,000, that is 1.2, right? And now on the right-hand side, that is 1 plus r raised to the 5th power. Okay. We're going to solve this equation for r. How can we do that? Of course, yeah, we're going to take a 5th root on both sides. Okay, we're going to take the 5th root. We're going to take a 5th root, or yeah, we're going to take a 5th radical on the both sides. Okay, so on the left hand side, that is base is 1.2. Take a 5th root, then that means that the power would be 1 over 5, right? And on the right hand side, 1 plus r raised to the 5th power, and then take a 5th root. Okay, then finally on the right hand side becomes 1 plus r, right? Okay, now from this equation, of course, it is easy for us to find out, yeah, to know r equals 1.5 raised to the power of 1 over 5 minus 1. Minus 1. Okay. Now I'm going to calculate. I'm going to operate the calculator to get the answer. Okay, the calculator. I'm going to clear the calculator. So first of all, I'm going to calculate 1.2 raised to the power of 1 over 5. The base is 1.2. Okay, how can we calculate the power? I'm going to use this key, y raised to the x, right? Y raised to the power of x. Okay, and then 1 over 5. Yeah, you can calculate. If you have a good mind calculation, you would know. Yeah, that is 0.2, right? Yeah, if you're not good at this, then we can calculate. Yeah, we can calculate. Okay, 1 over 5. I can put then in this case, yeah, I can put 1 over 5 into a parenthesis. Okay, so after we click this one, then I calculate 1/5. Okay, then the 1 divided by 5. Then close the parentheses. That is 0.2. Okay, and then click equal sign. All right, and then we subtract 1 from this from the value of this, right? Minus 1. Then we can get 0.0371337. Okay, this is in decimal, right? Yeah. Usually when we express the interest rate, we use percentage. We use percent. In percent, that is 3.71%. Okay. So that is just now. Yeah, we get R equals 3.71%, right? Okay, now we can use the financial calculator. Yeah, if we use financial calculator, the point is we have to in the time value function we have n y over I present value payment and future value. Okay. Because this is a single cash flow issue, right? Yeah, we want to calculate the future value or present value of a single cash flow. So PMT, we will not use PMT. Yeah, usually we clear the memory of PMT, or if you're not very sure about this, we assign a 0 to PMT. Now the point is, we're going to assign the values to 3 keys, and find the value of the 4th key, right? Okay, so in this case, we know the n. So from now on, generally, I'm not going to show you how to operate the financial calculator for the time value problem. Okay, I just briefly show you how to assign the value to keys, and then find out what we want. Okay, so in this case we know the n. In this case we know n, we know PV, we know the FV. We want to find out I over y, right? So what is n? N is 5. Y over y is what we are looking for. Present value is 1,000. Of course, we have to differentiate the directions of present value and the future value. Just as I said, we usually define present value as negative. Okay. And the payment is 0. Okay, payment is 0. Again, if you make sure that you have clear the memory of time value function, then you can skip this key. If you're not clear, you'd better assign 0 to PMT. And then future value is 1,200. Yeah, that is positive. After this, you click compute and then click I over Y. You can get the answer. Before we move on, I'd like to ask you a question. What is the unit of I over Y? What is the unit of I over Y output? Okay, just as I said, in terms of I over Y, percent in and percent out. In this case, I over Y is what we're looking for, and it would be an output with the percent as a unit. So I believe on your screen, it shows 3. It shows 3.75, 71. Okay. So that is how decimal places are there. It is up to your setting. Okay, it is, yeah. If you set 6 decimal places, then yeah, this number, yeah, the screen will show a number with the 6 decimal places. Okay, it is up to you. All right, so that is the how to calculate, how to find out the discount rate, or how to find out the rate of return. Now let's look at the second example. In this example, we're going to find out the number of periods. Okay, the number of periods of the life of an investment, or the length of an investment process. You want to purchase a new car, and you are willing to pay $20,000 if you can invest at 10% per year, and you currently have $15,000. How long will it be before you have enough money to pay cash for the car? Okay. Again, the question boils down to a time value issue, right? You have $15,000 in hand today, and you want to invest this $1,500 into a investment process, and you believe in this investment you can earn 10% per year. Okay, now you want to know how many years does it take your investment to be growing to $20,000. Right? We plug this number into the future value formula. So future value is $20,000. Future value equals present value $15,000 times 1 plus R. We know R this time, that is 0.10. In this formula, yeah, we have to use decimal and then raised to the power of t. T is what we're looking for, right? Again, yeah. How can we use math? To solve this equation for t? Okay, first of all, we divide both sides by $15,000. Okay, then on the right hand side, that is 20,000 divided by 15,000, right? Okay, then equals on the right hand side 15,000. Yeah, we know 15,000. On the right hand side, that is 15,000. Come on. Times 1 plus 0.10 raised to the power of t, then divided by 15,000. Okay, I'm going to simplify the expression. On the left hand side, 20,000 divided by 15,000. What is it? It is 4 over 3, right? 4 over 3. And then equals on the right hand side 15,000. This 15,000 in the numerator cancels this 15,000 in the denominator. So on the right hand side we have 1 plus 0.10 raised to the power. Right? Okay. Now after we get this, I'm going to take a log on both sides. Take a log on both sides. So on the right hand side, we have log 4 over 3. And on the right hand side, we have a log 1 plus 0.10 raised to the power of t. Right? Okay, now on the right hand side, yeah, we can write right hand side as P times log 1 plus 0.1, that is 1.1, right? 1.1. Okay. Now, yeah, we have this equation. We have log 4/3 equals P times log 1.1, right? And then we divide both sides by log 1.1. Then we have, okay, then on the left-hand side, that is log 4/3 divided by log 1.1. Then on the left and on the right-hand side, that is T. Okay, so finally, P equals log 4/3 divided by log 1.1. Okay, now after we get this, it is easy for us to use calculator to get the value of T. Now let's look at the calculator. In order to use the calculator, first of all we should find the key that represents the log function, right? Where is it? Here. It is this function. Okay, ln represents a log function using e as a base. Okay, this is the log function. All right. Okay, now I'm going to do the calculation. On the numerator, we have log. We have log 4/3. So first of all, we calculate 4 divided by 3. That is 1.3333, and at least 3. Okay, and then we take a log. Okay, and then divided by log 1.1. Okay, divided by log 1.1. I'm not very sure. Okay, yeah, to be safe, I'm going to calculate log 1.1 in this way. Okay, I'm going to put log 1.1 into a parenthesis. So in this parenthesis, I'm going to calculate log 1.1. Okay, 1.1, and then log. Okay, and then close the parenthesis. Then click equal sign. Okay, then we know T is 3.018377. Okay, approximately a little bit more 3 years. Okay, that means you have to wait a little bit more than 3 years to have enough cash to buy your car, right? Okay, so now let's go back. Let's go back to our slide. So T is rounding your answer to 2 decimal places. That is 3.0, right? 3.0. Okay. Now if you use calculator, then in this case, we know I/Y, that is 10%. we know future value $20,000. Payment 0. Present value negative $15,000. Then N is what we are looking for. Okay, after you assign these numbers to the keys in your time value function, then you can click compute and then click N to get 3.02. All right. Okay, so that is the second question. Next, let's move on to the rule of 72. In the real world, sometimes if you don't have a financial calculator, and if you have a simple issue, that is, you want to find out how long does it take for your money, for the value of your investment to double. Okay, yeah, for this simple question, if you don't have calculator, then we can use the rule of 72 to find an approximate number very quickly. Okay, so what is the rule of 72? For a reasonable rate of return, which ranges from 5% to 20%, that means okay, the rates, the returns between this in this range between 5% to 20%. Then the number of time units it takes to double the value of an investment is approximately 72 over the rate of return, with the R being in percentage. Simply speaking, if we know the R, if we know the R, and R falls in a reasonable range, 5 to 20%, and R should be expressed in percent. Okay, and then the number of the number of time units it takes to double the value of your investment is N. Okay, is N. And then the relationship. Okay, let me put it again. Okay, if we know, if we use R to represent the rate of return. Okay. And if we use N to represent the number of time unit for a investment to double in value. Okay. And then the relationship between R and N would be N is approximately equal to 72 over R. Here, there is a condition. R, first of all, if we want to use this formula, or if we want to use this approximation, N and R should be consistent, right? If N, the unit of N is year, then R should be yearly interest rate. If N is month, then R should be monthly interest rate. That is the first point we have to keep in mind. And the second point is, if we want to use this rule, the R should be expressed in percent. Okay, and the third point. Okay, if we want to use this approximation, it is better for R to fall in the range between 5 to 20%. Okay, if R falls in this range, then we can have a reasonable approximation. Okay, if R is out of this range, then the accuracy, would be a problem. Okay, so that is, and again, before we move on, we call this the rule of 72. Also, we can use the rule, we can apply the rule of 72 into the growth issue. Okay, why? Because here R, it is essentially it is a growth rate, right? It is a growth rate. Okay, so the rule of 72 actually, it is a rule of thumb that can be applied in the growth issue. For example, if we want to know if the GDP growth rate is 3%, the GDP growth rate is 3%. Then how many years it takes for the US GDP to double? Okay, how many years? GDP growth rate, yearly GDP growth rate is 3%. Now the question is, how many years does it take for the US GDP to double in value? Then we can use this formula. Then no problem. Again, give me a minute. Okay, 3%. 3% is out of 5%, out of this range, right? So let me see. Okay, let's say. The GDP growth rate is 6%. All right, that would be better. That would be more reasonable. Okay, let's suppose. Okay, now let's look at China. Okay, now let's suppose China's GDP growth rate is 6%. Okay, the question is, how many years does it take for China's GDP to double in value? Then we can use this formula, right? The N, N is approximately 72 divided by 6. 6 is in percent. Then we would know that is 12, right? It's 12. So it takes 12 years for China's GDP to double in value. Okay. Of course, we are learning finance. We want to know how to use this in finance. Okay. Now let's look at an example. You have $10,000 to invest. How long will it take your money to double in value if it earns 5% annually? Okay, and of course, if we use the rule of 72, then we can get this number, right? N, because we know N equals 72 over R in percent. So that is 72 divided by 5 in percent. Then we can get 14.4. This is an approximate number. Okay, so we can say approximately it takes 14.4 years for your investment to double in value. Of course, if we want to get the accurate number, then we have to use the formula. What is the formula? The formula should be, if we use future value formula, then that would be $20,000. Future value equals $10,000 times 1 plus R. R is a point. Come on. R is a 0.05. Then raised to the power of t. Right? T is what we are looking for. Okay. And of course, usually we don't use math to find out T. We use financial calculator. If we use a financial calculator, then in this case, I over Y is 5. Present value is negative 10,000. Payment is 0. Future value is positive 20,000. Then you can compute. You can click compute. Then you can click N. Then you can find that is N. The accurate answer for N is 14.21%. Okay, this number is more accurate than this number. Okay, when you run your calculator, there is a small tip. You don't have, because we're looking at the double issue, right? If you invest $1, how many? If you invest $1, then the future, you double the value of your investment, then you expect to receive $2. So in this case, you don't have to so much zeros when you operate your calculator. For the present value, you can just input -1. You invest $1 today, and you expect to receive $2 in the future. Okay, in this case, it will save your time, right? Okay, I believe, if you run your financial calculator, you can get this answer. Okay, if you don't, that means your operation is wrong. Then you can do that again or talk to me. Now, next example. Suppose you are offered an investment that will allow you to double your money in 6 years. What is the implied rate of interest? At the first glance, some students may ask, Dr. Chen, in this issue, in this question, we don't know the present value, we don't know the future value. However, please pay attention to this sentence that will allow you to double your money in 6 years. That means in 6 years, if you invest $1, you expect to receive $2. Right? So in this case, you can represent the present value with the $1. You can represent the future value with the $2. Okay. Now, first of all, we use the rule of 72. Okay. Now here, that is N equals 72 over R. R should be in percent, right? In this case, we know N. Yeah, we're going to double the value of your. We're going to double the value of our investment in 6 years. So N is 6. Then 6 equals 72 over R. Okay. Now we can solve this equation for R, right? Of course, with the small algebra, we know R equals 72 divided by 6. Then R is 12%. Okay. Of course, this number is not accurate. In order to get the accurate number, we have to use a financial calculator. In this case, if we use a financial calculator, then what is N? N is 6. Just as I said, what is PV? PV is -$1. You invest $1 today. Okay, so PV is -1. Payment is 0. FV is 2. You expect to receive $2 in 6 years. And then click compute, click I over Y. Of course, I over Y on your screen should be in the unit of percentage. Okay, that is 12.25%. That means, if you double your if you double the value of your investment in 6 years, over these 6 years, the yearly rate of return you will earn is accurately 12.25%. Okay. So now you can see the rule of 72 is very useful, right? Yeah, if you don't have a calculator, then very quickly, yeah, you can get an approximate number that is reasonable, right? Okay. Next, yeah, it is in-class practice. So here, I'm not going to discuss this question. Yeah, you can read the question and you can try solve this question by yourself. Okay, you can check whether your answer is right or not. The answer is on the panel. Yeah, it's on the note panel below the slides. Okay, you will find it. Okay, you will find it. Okay, that is all for chapter 4. And in this chapter, you have to read all sections. All right. And first of all, read the sections. And then, yeah, if you are confident, you can go to the homework. There is no problem. If you're not confident, and then, yeah, you can watch this slide. You can watch this video. You can read the slides until you feel confident. Then you can start your homework. Okay, if yeah, I believe, yeah. If you are confident, then you can complete your homework within 10 minutes and receive at least 80%. Okay, all right, that's all. That's all. Yeah, and now, yeah, we are going to move to the next chapter, chapter 5. Bye bye.